Hello everyone, in this video I'll be explaining you the problem sabotage. So it was asked in CodeChef Contest starter 208. So let's read out the problem. So Chef is participating in a programming competition. Currently he has a score of X. There are n participants other than Chef. Okay, so the ith of these participants has a score of A of I. Got it. So Chef's rank in the contest is determined as follows. Okay, so count the number of indices. It is one based indexing, so I is from 1 to n, such that a of I is greater than x. Okay, so and let this count be r. Okay, so okay, if this is the case, I mean x is score of chef and the people having score greater than x is counted as one of the in R basically they're counting, and the chef's rank is then basically R plus 1. Okay, so yeah, it is obvious. I'll be telling you on the board. Chef would like to improve his rank, so he decided to sabotage his opponents. So a sabotage operation is defined as follows. Okay, he has in order to improve he can sabotage his opponent. So what he is doing is choose an index I greater than 1, greater than equals to 1, less than equals to n. So basically all the indices he have, I mean for all the opponents, n opponents, he have the ability to do two operations. So the first operation is set their score basically of I to 0, and when he's doing that, so now he have to add 100 to his score, which is basically x, that is increase chef score by 100. So there is since there is not much time remaining, okay, chef can perform the sabotage operation at most k times. Only k times he can perform these operations at most k times. He can perform 0 time, he can perform 1 time, 2 time, up till k time he can perform, not more than k plus 1 time he cannot perform. So now the question is, find the minimum possible rank chef can achieve at the end. Okay, so yeah, this problem seems to be difficult, but it is very easy. I'll be telling you. It's a greedy approach where I will be sorting the array. So since okay, so the input format is like we have test cases. For every test case, we have three integers n, x, and k. As we know, like n opponents, and then x is basically the score of chef, and k is basically at most k times he can do sabotage operation. So the second line contains n space separate integers and basically the score of the other participants. So let's understand this example and understand. We have four test cases. In the first test case we have 4 151. We have n as 4 and x as 150. At most one operation you can do, and what are values? Values are basically 250, 375, 250, 375, 509, and then 12. Okay, so yeah, let's understand the problem. What they're saying is, chef is participating in coding competition. When he's participating in coding competition, his score is basically x. Okay, right now his score is x, and there are n opponents apart from chef. Chef is one of them, so there are again n opponents. So in total there are n plus 1 participants in the contest coding competition. So now the scores of these n participants are given as a1, a2, a3 up till an. So we have scores as this thing. Now chef's rank is basically defined as you'll have to check this a of I, the scores, if it is greater than x, it is strictly or equals to, let me check. Yeah, it is strictly. So we have, if a of I, the score of any participant, strictly greater than x. So you, let's say you take one r variable. So in that you will be basically taking the count of such participants. This is basically count of participants whose score is greater than chef. So obviously, like if there are r number of participants whose score is strictly greater than chef's score, so there are r people who has more score. So obviously the chef's rank will be r plus 1. Like let's say there are 3 people scoring more than chef. So like people 1, people 2, people 3. So your chef will be at 4th position, right? So his rank is basically 4. That's why r plus 1 is the rank. Rank is basically r plus 1. So now our task is basically to minimize this rank. So in order to minimize this rank, which means chef is better, so you'll have to minimize this rank. Chef is better. So in order to minimize this rank, uh, chef can perform sabotage operation. He can provide sabotage operations. So what are sabotage operations? What he will do is he can perform only k times, at most k times, right? At most k times. Is it looking? Yeah. So at most k times he can perform sabotage operation, because the timing is very restricted. So you have very less time, so he can sabotage only k k participants, not more than that. So in sabotage operation, what chef will be doing is basically he will choose the opponent. uh, let's say he is choosing opponent AI, and this I is from 1 till n, right? So he will choose this opponent, and he will make his score as 0, and the score of chef was previously x, and that is going to be increased by 100. Why he is doing this operation? Because he wants to maximize his score x, right? If he maximizes his score, so which means he will be scoring more, and once he score more, which means his rank will be less. Rank will be less. Eventually he is better performer. So this is the concept behind the problem. I think you guys understood. So now the question comes: how do we make sure that chef's rank is minimum? So it is very obvious, like the participants score whatever we have, right? So so this is a very greedy approach. Like whenever he do at most k sabotage operations, so in that case the score of the participant is going to be 0. If that score is 0, which means that is the least possible score, right? Which means he's done nothing. So if he's done nothing, and chef score is going to be increased by 100. So what we want to do is, the people having the score most, the people who has scored maximum, so you make that participant to be sabotaged in such a way that his score is going to be 0, and whichever element other participant having whatever score. So like basically at most k times, what you're doing is the participant is scoring highest, k highest participants whatever is there, their score you will be making it is 0, because his score is going to be 0, and then eventually his rank will be increasing, right? As I said, like whenever he makes his score 0, his other participant score 0, so chef's score is going to be increased by 100. So what he will do greedily is, he'll sort the array. Let's sort the array in decreasing order. So 509, 375, 250, and then 12 we have. So you have sorted now this. So what in the problem they've said, like you can perform only one sabotage operation. So this is the person whose score will be making it a 0. When you make his score a 0, other score remains same. Okay, and now chef's score was 150. His score will be increased by x plus 100. So which is going to be 150 plus 100 is 250. Now his score is 250. Now in this case, if you check how many people are there having score greater than 250, only one, that is 375. So now if you see people only one people, his score is strictly greater than 250. Now people 2 is basically chef, so his rank will be 2. Rank is going to be 2. I think you understood, right? So how many people are having score greater than x? It is 1. So his rank will be how many people plus 1? So this is the thing. I think you have understood. It is very greedy approach. In the problem, they have used 375. This is also correct only, but in order to confuse you, they've given. But actually, you will have to start this way. Like people having higher score, his score he'll be making it a 0, because let's say lower score people, if you make let's say 12 as 0, so it was already 12 was already lesser than score, right? Score of 150. It was already lesser, or the final score whatever will be there, so it is already lesser than this one. So you want to make sure that the people scoring highest scores, their scores has to be minimized. Let's say in this problem, if they give you in the second, they have given I think case 2 only. In the first example, yeah, answer is 2, chef's rank will be 2. So second example is same only, but at most 2 sabotage operation you can do. So here also it will be same. Basically you will have to sort the array in decreasing order. So now he is allowed to do 2 operations. So in the first operation he will make this participant score to be 0. In the second operation he will make this participant score to be 0. Now once he made that, so it was 250 when he was doing one operation. In the second operation again 100 is going to be increased. So final score of x will be chef will be 350. So you will have to check how many people are there having score greater than 350. No one is there. So he is the first person, right? He is the rank 1. So there's nothing 0. So 0 plus 1 is 1. So his rank will be 1. This is answer for second problem. So I think you guys understood. Basically the main crux of the problem was sort the array in decreasing order, and from 0 to k minus 1 elements you make it as 0, and then after that you will have to check the score of whenever you're making 0, make sure that you're increasing the score of chef, as said in sabotage operation. You're making score 0 but you're increasing score by 100. So let's try to solve it. So we have test cases. For every test case we have n, x and k. We have n, x and k. Let's take inputs, right? And then we have scores of n participants. So let's take inputs. We have taken input. Now we'll have to sort the array. So we'll be sorting in decreasing order. We can sort in increasing also, but I'll be sorting in decreasing so that it is more convenient. Like we'll be choosing I from 0 to I less than k. So at most k operation we are allowed, so we are doing this. So what we are doing in this operation, we are making this a of I to be 0, and then we are increasing the score of chef by 100. Once we have done this, now take rank to be initially 1. Why 1? Because in the next for loop we will be checking how many people are having score greater than x. So in that case like the answer is those peoples plus 1. So that's why I'm starting with rank 1. Now in this case I'll be checking if score of other opponent is greater than x, then your rank is going to be increased. So once you have done that, so you have got a number of people having score greater than x, so you'll have to display the rank. Let's try to run it. It got passed. Let's try to submit in the online editor. Sorry. Okay, so it got accepted. So I think it was greedy approach, and then basically you had to do sorting. And I think you guys understood the problem statement, and yeah, thank you guys for watching the video.